So our altitudes are going to be the perpendicular segment from a vertex to the line containing the opposite side. We've all heard of the word altitude before, I'm sure. What's another word for altitude? Anybody?
Height.
Height. Somebody said it. Height. Yeah. Altitude and height are the same thing. Okay. So this is what we typically think of when we think of the height of a triangle. When we're trying to find the area of a triangle, we have to find 1/2 base times height. This is the height, is the altitude. So we're talking about an altitude. If we have a triangle, right, we're talking about the perpendicular segment from a vertex to the opposite side. Okay, this is the altitude that we're looking at. And we're going to draw a picture in a second. Don't draw your picture yet. But that's what we're talking about in terms of altitude. Now, when we say, the wording's kind of weird, right? Because it doesn't say it's perpendicular from the vertex to the opposite side. It says it's perpendicular from the vertex to the line containing the opposite side. The reason for that is because of obtuse triangles. Okay, obtuse triangles, I can't draw a perpendicular line from this vertex to this side. I can't, right? I cannot go straight down and get to it. So instead, we need to think of that side being extended. Our altitude would then be outside of the figure. It's still considered the altitude here, even though it's not inside the triangle at all. Right? It's out here, but it's perpendicular from the vertex to the line that contains the opposite side. So that's why the wording is the way that it is. It's perpendicular to the line containing the opposite side. So, and that really comes into play only when we're dealing with obtuse triangles. If it's an acute triangle, then it's always going to be inside the figure. Okay, sort of like we talked about with the circumcenter at the beginning. It could be inside, could be outside, could be on the triangle. Okay. So let's do this. Let's draw ourselves a triangle in that third box. Let's draw ourselves a triangle. And let's make it an acute triangle. It's easier if it's drawn acute. Just an acute triangle there. And then what we want to do is we want to go perpendicular from a vertex to the opposite side. So if you have a triangle like this, the first one is easy, the straight up and down, because you're just going straight up and down, right? Going straight down from that point. Just notice that depending on what your triangle looks like, it's not necessarily the midpoint. It's not, right? It's just perpendicular. Right? And then do the best you can on the other ones to go perpendicular to that opposite side. So from each vertex perpendicular to the opposite side. And really, we don't have any markings on that triangle other than the perpendicular, because we don't know anything is congruent to anything else. Okay, there's nothing congruent here. We don't know that this is a midpoint. It's not necessarily a midpoint, right? Pretty clearly here, it's not. It's not an angle bisector, right? Nothing is congruent to anything else. The only information we have is those 3 right angles. Okay, and that's it. Any questions on what an altitude is before we talk about that point of concurrency? Okay. So that point of concurrency is called the orthocenter. Of course, we just want to make it confusing with the other ones. So circumcenter, incenter, now orthocenter. It may be inside or outside the figure. We'll take a look at that in a second. And leave a little bit of space on that box because we'll come back and we'll write something in about right triangles here. I don't have that down yet, but we'll add it. All right, so we've got our orthocenter there. So let's take a look at an example here.
Oh, Dante. Hi, buddy.
All right. So we've got our triangle. I've got my altitudes drawn in, right? It's perpendicular from the vertex, perpendicular to the other side. Vertex perpendicular to the other side, right? All three. They are concurrent. They're orthocenter. All right. So let's take a look at what's going to happen when we don't have that acute triangle anymore. We go to an obtuse triangle here. Right? We know these are still perpendicular. These are still altitudes. Okay, and I know it's kind of hard because of everything, all the lines and everything that are in there. Hard to visualize maybe. But if I'm looking from point A, I need to go perpendicular to the opposite side. So I would extend this side out. There's perpendicular. Right? From point B, I got to go perpendicular to the opposite side. So I extend that side, that's perpendicular. From point C, that's perpendicular. So all three are perpendicular. They're just going to happen to meet outside of that figure. And depending on how big your obtuse angle is, right, the bigger this obtuse angle, the further away this point's going to be. It's going to be further away. If it's barely an obtuse angle, then it's not going to be that far outside the figure. What do we think is going to happen if I make this a right triangle?
It's going to be on the right angle.
Yeah, it's going to be on the right angle. Right? When I make this, it's closer. It's closer. Once I turn that into a right triangle, now it's on the right triangle. It is the right triangle or the right angle. Right? Because I look at that now, A perpendicular to this side is right there. B perpendicular to this side, again, right there. This is perpendicular, but it's going to head right through that vertex. Right? It has to be at that vertex. So in a right triangle, everything's going to that vertex. So on your outline, under where we said it could be inside or outside the figure, also put on there right triangle, it is the right angle. Or something about that, right? For a right triangle, it is the right angle. So I don't have that on there, but right, if I did, I would probably say something like right triangle means on the right angle or something like that, right? As long as we got something like that down, then we're good. All right, good news, bad news. Good news is there's no theorem. There's no theorem. There's nothing that we can say specifically about the orthocenter. There's nothing that we can say. Okay? There's nothing congruent to something else. There's no relationship between the segments, right? Nothing like what we've seen before. So we've got no theorem. We've got no extra information. That's the good news.
What's the bad news?
The bad news is now we got to do a hard type of problem because we got to find the orthocenter on the coordinate plane. Okay, and that's what we're gonna have to look at. Okay. All right, so we're gonna find it on the coordinate plane. Let's graph paper up here just so we can visualize it maybe. Not that you'll need graph paper, I don't think you will if you do it correctly. But we are going to look at it in the coordinate plane. Okay, actually, I'm going to put that up there. So I want you to go ahead, I want you to sketch that graph out. Okay, sketch those 3 points so that we have it in our notes. This should be notebook. It should be in our notebook here. All right, so we sketch our figure, okay, because we always want to visualize what we're dealing with. By the way, this is the only type of question that we're going over today. The only other things that you have to do with OrthoCenter is to identify it, is to recognize when they're giving you altitudes, okay, and know that, yep, this is called the OrthoCenter. So this is the main thing that we're dealing with today. And this is going to be very similar to when we were finding the circumcenter. Very similar. There's just a small difference, and we'll talk about that at the end. So the first thing that we want to do is we want to find our easy altitude. Always find our easy altitude. And by easy, I mean either straight vertical or straight horizontal. To do that, I'm going to find either a horizontal or a vertical side. Because if I find a horizontal or a vertical side, then I can go perpendicular to that and find the easy one. All right, so here's my horizontal side. So then here is my easy altitude right there, right? From the opposite vertex straight down. I know that my orthocenter needs to be on that line somewhere. So what does that tell me? What has to be true about my orthocenter since it has to be on that line? Cool?
X equals -2.
X equals -2. I know I've got -2. Right? Very similar to the circumcenter. We did the same thing. We drew in that easy that easy perpendicular bisector, and we knew either our X or our Y value. Same thing here. All right, so we know it's got to be on that line. We just got to figure out where on that line it's going to be. So we need to create an equation. Hopefully this sounds familiar. We're going to create an equation. So you need to pick one of the other sides to go perpendicular to. It doesn't matter which one. Now, since I've graphed this, I can visually see that this is a much nicer slope than this is. I can look at this, and since it's cutting through boxes on a diagonal, I know that slope is -1. So that's a much easier slope to deal with. And not to say that we couldn't do it with this one. It's just going to be easier if I use this one, okay? If you see it. So you're going to find that slope. That slope is -1, right? Down 1 over 1. That's a -1 slope. So I know my perpendicular line needs to have a positive 1 slope. So I know my new slope, my perpendicular slope here needs to be a positive 1. What point do I know that that line has to go through? This altitude that I'm about to draw in that goes through, that is perpendicular to this side, what point does it have to go through, Tyler?
-1.
Yeah, it's got to go through this vertex, right? It always has to go through the opposite vertex here. So I know it's got to be perpendicular to this line and through this opposite vertex. So I'm going to use the point -5, -1. Right? Because I want this perpendicular line here. So it's perpendicular to the side, so get the slope, make it perpendicular, and make sure it's going through the opposite vertex. Now that I have a point and a slope, I can put it into point slope form. Y plus 1 is equal to 1, x plus 5. All right, put it into point slope form, and I already know that x is -2. So take that -2, plug it in for x. And then I can solve for y. This is very, very similar to that circumcenter. The only difference between what you did for circumcenter and what you're doing now is the point that you're using to create that equation. Right? For circumcenter, you use the midpoint of this side. For orthocenter, you're using the opposite vertex. That's the biggest difference. I would write that down. Okay, write it down so we can stay clear. For circumcenter, we're using the midpoint of that side. For orthocenter, we're using the opposite vertex. For circumcenter, we were using the midpoint of that side. Orthocenter, we're using the opposite vertex. And once I use that equation, I plugged in my -2, I get y is equal to 2, so my picture is not great here. What it should end up being, right, and this is why we can't trust our pictures, it should end up being right there. Because that's where they're going to cross, -2, +2. Okay, so that is our process. Find your easy altitude. Then take one side, find the slope, make it perpendicular, and make it go through the opposite vertex. Any questions on that before I have you try one on your own? Okay. This is not the one that I'm going to have you do on your own. I just want to look at it. Okay, looking at number 7 there. What type of triangle is it? The right triangle, right? The x's repeat, the y's repeat. Remember, if the x's repeat, the y's repeat, it's a right triangle. And the point that has both of the repeating numbers, that's your right angle. So the -3's repeat, the 4's repeat. That means this is my right angle. Where's my orthocenter going to be? Right here, right? My right angle. So my orthocenter would be -3, 4. If you recognize that shortcut, right? If you recognize that it's a right triangle, then that should be an easy problem. It's going to save you 5 minutes on the test if you recognize that. If we have it. I'm not saying that we will, right? But on the homework, it would save you a lot of time. Right? So we're going to do the other one. The other one, this is not a right triangle. So we do actually have to solve this one out. So we're looking at number 6. Go ahead and find the coordinates of the orthocenter, please. Start with the easy altitude. Take another side, perpendicular slope, opposite vertex, create the equation.
money for
Sure it does. My axis repeat, I've got to. It's got a vertical side now. If you're still working, that's fine. I want to point something out real quick though, just to make sure we're starting off correctly. We got an obtuse triangle here. Okay, it's an obtuse triangle. So where is that orthocenter going to be? Outside. It's going to be outside the triangle. We know that, right? It's got to be outside. So when we look for that easy altitude, find your vertical or horizontal side. This time it's vertical. Go to your opposite vertex and go straight across to it. So it is going to be outside the figure, right? But there is our altitude. So that tells me that y is going to be -3. That's the line. Y is equal to -3. So I know it has to be on that line somewhere. Then look at one of your other two lines. Find your slope, find your perpendicular slope, use the opposite vertex. I'll give you another minute or two to go from there. All right, let's take a look. So we got to pick one of the other two sides to go off of. Okay, do you want to use BC or do you want to use AC? Somebody tell me.
AC.
AC, sure. We'll use AC. Okay, so whatever side we're going to use, we have to find the slope of that line first, going from A to C. So if I do that, I can use slope formula, right? If you don't trust your picture, use slope formula. Subtract my y's, subtract my x's. I'm going to end up with a -1 slope again. Okay, so I've got a -1 slope here. Make it perpendicular. So my perpendicular slope is a positive 1. And then what point is it going to have to go through? Okay?
I believe it would be negative 1, 6. Negative 1, negative 3.
I'm not talking about what the answer is. I'm talking about to create this equation, right?
Yeah, 0, -2.
It would have to be going through 0, -2. It has to go through that opposite vertex, right? So I use this side, make it perpendicular. It's using the opposite vertex. So the one that you didn't just use to find the slope, you're plugging in. So that's 0, -2, right? Perpendicular slope, opposite vertex. Put this into y equals mx plus b. Well, this is an intercept, or put it into point slope rather. If I put it into point slope, right, that's going to be something like that. We could change it over to y equals mx plus b pretty quickly, but we don't need to, right? We know that y has to be -3. So we plug in the -3. That's just going to give me x. And so x ends up being -1. So that means our point here is going to be -1, -3. It's going to be right here, right? So this is going to head through somewhere over there, but it's going to head through this point. That's going to be our solution. -1, -3. Any questions on? Yeah.
Yeah, I have a question. How do you know what point to use? Like
you have to use the opposite vertex from the line that you found the slope of. All right, so we found the slope of AC. Slope of AC, we need to use that third vertex as our point.
Okay, so you used B. The B
Yep,
vertex.
exactly. Yep. AC to find the slope, make it perpendicular, and then I use point B as my ordered pair.
Okay.
I want to look at this real quick. Let's say that we chose BC instead. Okay, I chose BC instead. That's down 1/6. So I'm looking at a -1/6 slope here. So if I make that perpendicular, that's going to be a +6. Right? So now I'm using BC. I'm doing it a second way here. Just in case you chose this one. So this was a -1/6. I make it perpendicular. Now I've got a +6 as my perpendicular slope. And I know it needs to go through the opposite vertex. I used BC to find the slope. So I need to use point A as my ordered pair. So I would use 0, 3. Okay, because I'm taking this and it's going to be perpendicular here, right? It's going to be perpendicular to this side. It's going to be perpendicular right there. Okay, so I've got a +6 slope. I know it goes through the opposite ordered pair, the opposite vertex. So y -3 is equal to 6, x -0. I know still that y is equal to -3. That's going to give me -6 is equal to 6x. X, again, is -1. So it doesn't matter which side you use there, as long as you're finding the perpendicular slope and using the opposite vertex to create that equation. Okay. All right. Any questions about that? I did have a question on here. It says, will there ever be a triangle that doesn't have a vertical or a horizontal side? If there is, then it's extra credit. Okay. So let me show you just in case that shows up, right? Let's say that we have something where we don't have a horizontal or a vertical side. Then that process that you just went through to get this equation, right? That find the slope, make it perpendicular, and use the opposite point to create that equation. We have to do that twice. So you would create 2 equations out of it. So you would, take the slope here, make it perpendicular, use this point to get 1 equation. Maybe you take this slope, make it perpendicular, opposite point, create a second equation. Once you have 2 equations, right? Let's say we have 2 equations. Once you have 2 equations, you got to solve it using a system of equations. Right? So that's substitution or elimination, which we haven't done in a while. but that maybe you could look up. Okay. So yeah, you would just create two equations, and then you'd have to see where those two equations cross using the system. Yeah. But most of the time, right? Most of the time, 95% of the time, you're going to see a horizontal vertical side.